All right, let's get started. So, hey everybody, this is Rob Galvin. I work in the developer community for the RhoMobile team. You may have seen me on Launchpad, um, as well as work. My team works on the online documentation for RhoMobile. So today we're going to go over the RhoMobile Suite 4.0 JavaScript APIs and kind of give you a tour of what's new for our JavaScript support. So for version 4.0 of RhoMobile, we really had a strong emphasis on JavaScript. In the past, previous versions, we've had JavaScript support in a variety of different forms. And for this release, we really had an emphasis on consolidating some APIs that may have been duplicative, as well as provide a foundation going forward for all APIs that are developed to run on both JavaScript and Ruby. So you really have a strong choice when you decide to develop RhoMobile applications. So in this release, we translated a lot of the previous APIs to this new format and really focused on our strengths. So one of them being device capabilities with barcode reading, card reader APIs, as well as having some new APIs for some of our new devices that have some new sensors. And we've also provided some new APIs for accessing our ORM or our data layer, including connectivity to RhoConnect applications and synchronization services. And of course, we included a set of core APIs for accessing either application level information, configuration information, system level information, or as well as the framework. And I'll go into each one of these APIs in a minute to give you an overview. We've also included, like we have in the past, some native UI components. So tab bar, toolbar are APIs where you can actually provide some native UI to your applications. Native UI controls. We do have support for previous JavaScript APIs in the form of 2.x row elements APIs, and I'll cover that in a little bit more detail. What's new for this release as well is support for your own native extensions via JavaScript. So in the past, we always had the ability to create native extensions where you may want to provide some capabilities for interfacing with some native SDK, and those were done primarily through Ruby, through generated code. And now our native extension generator actually generates both JavaScript and Ruby layers. So we'll talk a little bit more about that later on. So here's an overview of our RhoMobile Suite 4.0 JavaScript APIs. So let's talk a little bit about how these APIs are put together, because it's a little different than in previous versions. First of all, you have to understand that each of these APIs are put together as in the form of an extension, a native extension. So just as you could possibly decide to write your own native extensions, we have written all of our new APIs in this form. And it's important to know this because you may want to include or disclude certain APIs in your application, and they're put in. Each API is put in an extension. So, for example, in this graphic, you can see that each of the extensions are kind of highlighted in white there with the graphic, the plug symbol next to it. And so, in the case of the core API extension, we include application, database, row file, all those sets of APIs. Okay, so these sections here are the extension names, core API, media player, screen orientation, etc. And then under each of these extensions are the set of APIs that belong in them. So if you're familiar with our build time configurations, our build.yml, we have an extensions section in there where you can include these API extensions in your application. And I'll explain how this JavaScript API comes together. But just know that all of these APIs are built as an extension. You'll access them in your application in your JavaScript by using the Rho namespace. So it'll be Rho.barcode, Rho.cardreader, Rho.mediaplayer, etc., followed by the appropriate property or method name that you're trying to use. In this example here, we're just doing a Rho barcode take. Take is a method for the barcode class that will turn on the scanner and process the scanned data. In order to use these APIs, these new JavaScript APIs, you'll have to include this file called RhoAPI-modules.js. This is different than in the past in some cases. In the previous versions, we had two sets of APIs, essentially. We had a Rho's set of JavaScript APIs, and we had a set of RhoElements JavaScript APIs. The RhoElements JavaScript APIs in prior versions were built as a Netscape plugin, so you didn't have to include a special file. But in version 4.0, you actually need to include this file so you have reference to all of the Rho objects. Okay. A little bit more about how the APIs are packaged together. When you install RhoMobile Suite, there are essentially 3 gems that package up these libraries. There's a roads gem, which is available to see, and this is kind of our open source library. You can see the code behind all of these APIs. These are free to use. Okay, and these include the following extensions, which include all of these APIs listed here. Then there's a RhoElements gem, which is installed, which you can optionally use, which includes some enterprise class features like barcoding, card reader, and some of these other extensions here. There is a license to use those. You can develop with them for free. They're fully functional. There's a nag screen that pops up. But those are all packaged under the RhoElements gem. You can decide to include individual extensions. Like in this case up here, we decided to build an application which just had the barcode and the indicators extension. And if you'd like to just include them all, you may have seen this reference before in the build.yml for app type as RhoElements. When you do this, when you specify this in the build.yml, you're essentially saying make sure to include all of these APIs and extensions available to you. Okay. New in 4.0, the RhoConnect client is actually removed from the core API or the roads gem, and now it's included as its individual extension. So if you wanted to include RhoConnect client client in your application, you would have to include a RhoConnect gem. Okay, and when you generate an application by default, it doesn't include this as an extension. But these are all controlled from the build.yml, and if you don't specify anything, you're basically just going to get the core API level of extensions and APIs available to you. Okay, so this is important because as you're starting to explore these APIs, you may bump into the case where, hey, I'm trying to do a screen orientation method to rotate my screen and it's not working. Well, you probably forgot to include the screen orientation extension listed in your application. Okay, so let's go through a couple of different scenarios that you may encounter when you're trying to use our JavaScript APIs. The first one is if you're just building, I'm calling a native application. So this is if you're going into Rho Studio or your IDE of choice and generating a native application where all of the files are going to be running locally. You're going to take advantage of our local web server that's running within the container for the application. And you may decide to use our Ruby MVC. You may decide even to just do straight HTML and not use Ruby at all. But the point is, all of the files are local to the device, kind of running within our web server infrastructure. When you build this type of application, the JavaScript file, this RhoAPI-modules JavaScript file, is actually built every time you build your application. So when you go through RhoStudio and generate an application and build for Android, let's say, the RhoAPI JavaScript file is automatically generated and it looks at your configuration. So like I said before in the previous slide, it'll look at your extensions and include all of the JavaScript objects in here. So, and this is done every time you build, and it's per platform as well. Okay, so this file will be available to your local running application in the public API folder. So you would need to reference it in your application. Okay. And when you install the APK or cab file on the device, it will install this file and will be available to your application. Okay. In this case, you can also access some of our Ruby APIs via JavaScript, and I'll go over some details on that later on. But the important point here is that this API file is packaged with your application automatically. There's really nothing special you need to do. You just need to make sure it's referenced properly in your local pages. Okay. The other scenario is, let's say you have a web application. You already have a web server. You want to enable some of our APIs, our hardware APIs to your application. And in this case, you can't do this with a standard browser. So you decide to build what I'm calling here a web container, where essentially it is the same thing as a native application, but you're pointing the application to your website instead of running your code locally. You're running the HTML or ASPX, whatever your backend is on your web server. But you still want to take advantage of our JavaScript API. So how do you do that? Well, you build your web container, which you may package up as a kind of your own branded application, and you're pointing your application to this web server. You need to have the JavaScript API file running on the web server. So you would copy this file over to your web server and reference it properly in your web application, and then you'll be able to use those rho.barcode, what have you. Now remember, keep in mind that when we build our native applications, this is taking all of these extensions here and packaging it up and creating a customized RhoAPI-modules, and it's per platform, right? So if your web application is serving different types of clients, you kind of need to have a universal API file here, okay? And you have two choices. You can either build one, right, using the project that you set up here, or you can download it from Launchpad, and I'll get to the download in a second and explain the differences. The reason why you may want to build a custom one is, remember previously, if you decided to build your own native extensions, okay, and you include your custom extensions in here, when you go ahead and actually build this JavaScript API file, it's going to be for your project. Okay, if you just want to just have everything available to you that we provide, then you might want to just download the universal version, which kind of has this platforming already set up. But in the case you need to build it, there's a simple rake command, and it's rake update RhoModules JS with a parameter of all, and it'll generate this file and put it in this folder, and then you copy it to your web server. Okay. Keep in mind that the 4.0 APIs are available for on Windows Mobile. It's available on Motorola WebKit, which is the default WebKit that's used, and on all the other platforms, we're using the native WebKit now on these platforms. So these are the platforms that these new APIs will be supported on. Okay, the other scenario is very similar to this web container, but it's the special pre-built web container, which we call the RhoElements shared runtime. And in this version, we're providing a Windows Mobile version of this. So this is only available on Windows Mobile. And the runtime is something that's kind of a pre-built container, like I said, which has our branding on it. Really no customization. It just allows somebody, it's more of a convenience where you don't have to build an application. You can just install this cab file that we provide to you, and then you can create shortcuts, right? Your shortcuts on your device could point to a local set of HTML files, or it could also point to a web server like we had in the previous scenario. If you plan on having local HTML files on your device, then when you install this cab file, just like in a regular native application, we include a RhoAPI modules file in the installation, but you have to pay attention to where your local HTML files are, and that they have the proper reference. So after you install the cab, the shared runtime cab on the device, you'll see the folder where the API file is, and you just need to reference it properly so that you have the APIs available to you. Or you can copy that to wherever your web pages are locally on the device and reference it that way. But the bottom line is make sure that the API files are referenced in coordination to that. Now, if you're using the shared runtime and pointing to a web server, just like you did before, then the same rules apply that it does in this scenario, where you probably want to download the universal version of this API file so you have all situations covered, and host that on your web application. Okay. So let's talk about the universal RhoAPI modules.js. So this is included in the installation, but it's also just available for you to quickly download from Launchpad. So you go to developer.motorolasolutions.com and download the software. In addition to the RhoMobile Suite installation packages, you'll see this common JS API file. This includes all of the 4.0 APIs that we presented before in this slide here. Okay, so it includes all of these in this JavaScript file. Includes all of the extensions. So take note that there's this set of these that need a license, that require a license. So if you're just looking to use the open source APIs, you probably want to do the build option. But this universal API file is available for download. You can see the size difference here. It's not tremendous, but there is a size difference for the full package versus if I just use the core APIs in terms of byte size. So that might be something to consider. You can use this typically, like I said before in the previous slide, with the shared runtime or your native web container app. This is really for the hosted web app. So web app that wants to expose RhoAPIs via JavaScript. This is the file that you would probably use. It doesn't, like I said before, include any optional extensions or custom native extensions that you may need. Like I said, it's available for download on Launchpad for convenience. You always have the option of building this API file based on an application that you may have set up. Okay, so let's talk a little bit about, I mentioned before that we did a lot of consolidating our 4.0 APIs, our 2.x APIs into this new 4.0 structure. Some of them didn't make the cut, and you may still want to use them, and you still can in some cases, in most cases. So there's a set of, like I said before, RhoElements APIs that were available to you. If you look at the 2.x documentation, we had this matrix which talked about MSI devices, and these are the RhoElements APIs. Again, these are available only on Motorola WebKit, Motorola Solutions devices. And all the rules that applied before in 2.x still apply when using these APIs. There's no additional JavaScript file that you need to include. These were written as a Netscape plugin and are just available. So in this case, in this example, I'm using a generic API, which is one of the RhoElements 2.x APIs, and I'm using a set registry method to write to the registry. So we don't have an equivalent 4.x API that does the same function, but it is still available to you under these conditions. All right, so let's talk more about what is supported on 4.x, right? So let me, to do this, I'm just going to jump over to the documentation site. It's a little bit easier to show you that way and point out some of these things. So let's go over to our documentation site. And when you go to the documentation site, you'll notice that we have a new way to see versions of the doc. So by default, it's pointing to 4.x. As I just mentioned before, support for 2.x. If you clicked on 2.x here, it would change the whole kind of mode of the documentation site. But when you go to the API reference under 4.0, you'll see this API summary, which talks about the new 4.0 classes that we have and the languages that we support. Notice that we're really striving to support everything on JavaScript and Ruby by default using this new native extension method that we're providing. And then the platforms that the APIs are supported on. Okay, you can see that some of them indicated by the shopping cart here are things that require a license. So you'll say, look, well, how come everything on Windows Mobile requires a license? Well, anything that's running Motorola WebKit requires a license, and that's what we use on Windows Mobile. But the other APIs, you'll see support on the different platforms at the API level. Now, also, as far as platform support goes, we have indicators under each of the methods and properties for the particular API. So if I click on, let me go to enable, barcode enable, you'll see under each method a indicator for language and operating system. So in addition to the top level, which kind of overrides everything, you'll see indicators at each of the individual methods and properties. So in this case, this particular method is only available on Android, Windows Mobile, and Motorola Solutions devices, which support a hardware or software trigger. This is to enable the scanner button on the actual device, the hardware button. So if I look at kind of an equivalent universal method, the barcode.take, this is available across the board and will allow you to scan a barcode. Okay, so this is how you would see if certain things are available on different platforms. You look at these indicators here. Okay. So now let's just kind of go through and give you an overview of each of these APIs and just kind of a quick tour. You can look it through the documentation. But you'll see in the documentation, you'll see that each API really kind of has a listing of the methods, the properties that it supports. These are the two main areas you'll probably be in. There's a set of examples on some of the key use cases, and then some remarks or things you may have to consider when using them. And that's essentially how they are constructed. They're all kind of following the same model. What's important here is that we do remind you in the beginning that in order to use this API, what extensions are included, or in this case, it's kind of pre-bundled into this RhoElements package. So let's kind of go through each of these APIs and give you a quick overview. The application API will give you access to application level things. So for the most part, it's a lot of the properties you'll probably end up be using on this. So things like where certain things are stored, if you're capturing images or saving, blobs in your ORM, this property, we'll talk about that. If you want to have information about the version or the title of the application. So it's all about your application and settings around the applications. As far as the methods go, they're for the most part the mostly used methods for application classes. Quitting the application, or in the case of Windows Mobile, minimizing and restoring it, and as well as setting application notifications. Okay, so this is a common task for application. Barcode's pretty self-explanatory. This is for scanning barcodes. We combined two previous APIs, one that was called barcode and one that was called scanner, and this allows you to scan barcodes. A lot of the properties here are really just for Motorola-specific devices. When it comes to decode engines and decode engine settings, there's a ton of them. And for kind of universal access, we have the take method, which is kind of the mostly used API for just scanning a barcode across across different devices. We'll talk about the parameters and the callback handlings in a minute. But let's cover the rest of the API. So battery is an API where we want to check battery levels. Okay, so this is about setting up callbacks for handling battery status if you want to do something before the battery gets too low. Okay, there's also an icon indicator if you want to show a battery icon. Card reader is for reading MagStripe cards or credit cards. MC40 has a built-in card reader, so that's an example of reading a card reader. This is only available on Motorola Solutions devices right now. Database is about kind of low-level access to the underlying SQL database, and in this case, most of the time, this would be about transactions if you wanted to do some transactional type of interfacing with the database. Key capture is capturing hardware keys. So again, this is more so on the enterprise MSI types of devices where we have hardware keys, special keys that are on the device you may want to expose in your application or use in your application to do something, right? So you can set up key capture there. And we set up keys to capture and what to trigger and all that good stuff. Key state is again on the hardware keys for the device. So if you wanted to put it into numbers mode or alt mode, function mode, there's a lot of special keys on a lot of our enterprise types of devices to do certain things. So this is the ability to control that. We have logging API. This is pretty self-explanatory to log things to our RhoLog. So you can set up things like different categories or reading the log file, erasing it, sending it off to a web server. Maybe you want to set up some sort of help desk functionality in your application or interfacing with a help desk system. Okay, so this is logging, pretty self-explanatory. Media player is for playing back different types of media objects. So ringtones is kind of the old, I don't know if people still use ringtones, but yeah, so ringtones are there. This kind of came from the legacy consumer side. Playing video and stopping video. Okay, so these are some media player actions. And then we have a set of native UI. So native menu bars, native tab bars, native toolbars. These are true native class UI controls that you can put in your application and take advantage of it. I would say the most popular is probably the tab bar and the toolbar. Tab bar allows you to get multiple instances of our web view to expose different pages. So that's usually used on Android and iOS. Nav bar is something that's available on iOS only. So these kind of components here are all about UI, native UI controls. The network API class is about interfacing with the network, whether it's a WAN or a Wi-Fi network. A lot of the use cases I see is detecting network changes of status. So particularly when you're interfacing with our sync engine, you may want to set up a notification for when the network is available and then to trigger a sync, right? Or to do certain things on network activity. We also have some things about downloading files. Some of the async APIs were combined into here. So the get, the download file, post, these are all async types of activities you can now do with using our network API. And then you can also, provide some properties to some of these parameters as well. Notification API class is about notifying the user either through audio or some sort of tactile feedback, visual feedback. So we have a couple of different methods for that. Vibration is, vibrating device or beeping, playing a file, and showing a pop-up. So there's different ways to do pop-ups, but if you wanted to take advantage of the notification API, you can do that. Then we have some ORM APIs. ORM, and I have a whole bunch of slides on ORM, so I'll cover that in a minute. But ORM is essentially our interface to our database layer, and this is the abstraction of the SQLite database under the covers. Then we get into some RhoConnect features. So push is about push messaging, whether it's through Google Cloud Messaging or Apple Push Service, or RhoConnect Push Service as well, right? So this allows you to do some push notifications and to manage that. So it's more about the properties, setting up the right push server and the different types that you'll be using. RhoConnect Client used to be called Sync Engine. So for those of you familiar with Sync Engine, it's now called RhoConnect Client. So this will allow you to trigger a sync, set up notification handling for as things are syncing, if you want to display status, etc. We have a file API, file IO. So if you wanted to access the file system on the device, you can do that through some of our file API methods. We have a screen orientation, which is about, it's pretty obvious, changes in rotation. So you can set up notifications for when the orientation has changed, or you can also, set what the screen orientation would be with just these easy to remember, left-handed, right-handed, upside down methods. Sensor is kind of an interesting new API. We have some new devices that have a variety of different sensors on them, and we feel that there's going to be more devices that have even more and more sensors. So this API is interesting to use. It may not seem much in terms of our classes listed here, but you essentially will define a sensor by type, okay, and we have all these types listed here: accelerometer, orientation, e-compass, magnetometer, gyroscope, ambient light, proximity. So like you may have seen some of those commercials for the Samsung where they kind of detect or wave over the device and it does something. So this is about proximity sensors, right? So if you want to do things in your application where you just want to hold your hand over the device for 2 seconds and it would trigger an action. You can take advantage of the sensor API to do that. So you kind of set up this sensor object and then you would define some parameters on when you want to be notified of things that are happening with that sensor. Signal indicators is an API where we're basically allowing you to show Wi-Fi signal with status. So you can set up some methods to handle changes in signal strength if you want to alert the user that they're going to lose connection soon. However, you can do that with the signal indicator API. System is for the Rho system or the framework itself. There are several methods and properties that are available to you. Probably one of the most used properties in here is detecting the capabilities of the device. So whether it has a camera or is a Motorola device, is a simulator, right? So those are some of the things you probably want to use, as well as getting access to the OEM info on the device, maybe some of the resolution or how big the device is. So there's a lot of information in the system class for you to take advantage of in your application. As far as the system method goes, there's many different methods that are available. The ones that are in red here are ones that are supported, but are deprecated. So there's usually a corresponding in this case, use network clear status notify instead, right? So this has kind of been deprecated. And then you'll see things like application install, which is highlighted in blue, and that replaces a previous API. Okay, so that's some of the color coding there that you want to be aware of. The last API I want to mention is WebView. We've had this before, and this is basically the control of the behavior of the container that you're running your application in. So there are many things to do about cache sizing, enable caching, user agent, the zooming of the text or the page, viewport settings. So all about the actual WebView container is accessible through this WebView API. Okay, so that's the tour of the new APIs. Let me jump back to the slides and cover that. All right, so you may have seen some new types of parameters when we were going through the API. So we have a new property type that we didn't have before, and you'll see reference to it in the API documentation as property map. So in this case, I'm looking at the battery API, and I'm looking at the battery status method, and it takes two parameters. The first parameter is this, we call it a hash. So in Ruby, it's called a hash. In JavaScript, it's really called an object, but we just reference to it as a hash, and we call it property map. Now, a lot of the APIs will display what the actual object is right in the documentation. So for this case, if I wanted to do row.battery, and I wanted to say, I want the trigger for the battery status handling to be a periodic. I want this to fire every so often. Then I'm going to pass in this object here, and the object is essentially a JavaScript object with two parameters. The first one is trigger, and it's a string, and it indicates the possible values in this case to use. So I can use this constant here. And the second parameter for this property map object is called refresh interval, which is an integer, and I'm going to pass in 1,000 milliseconds. So this is the first parameter of the battery status method. Okay, so this property map here. I'll talk about callbacks in a minute in the next slide, but just want to make sure you're aware of this property map and how to use it. You'll see many different APIs use this property map and explain this here. Barcode has used it in a couple of cases, and it's a special one because it actually it says it in the documentation. There's a little misspelling there, I guess, but it says it in the documentation, and you can essentially pass in any property that's available to the barcode object that's supported on that platform. So in this case, if I wanted to do a barcode.take, the documentation doesn't list the 214 properties, but this will take the properties that are available. So I'm going to say remember this first object here is this property map, and I'm going to say aim mode, which is a valid property on barcode. I'm going to set it to aim mode dot, and decode volume is another valid property in barcode, and I'm going to set it to 0. So when I issue this barcode.take, I'm actually setting these properties, and then the callback handles the response. So this is a little special case for property map, but for the most part, it's highlighted in the documentation to what is available to you. Okay, let's talk about callbacks for a minute. So you'll see reference in the API documentation a lot about a callback handler, a parameter for a particular method. So there's a couple different ways you can do the callback methods, and we'll walk through some of those in a second here. But when you're looking at the API and it references a callback handler, there's kind of two tabs you need to be concerned about when you're looking at the documentation. The first one is the parameters tab, which describes the parameters for this method. So in this network start status notify method, there's a poll interval, and then there's a callback handler. And this will tell you if the callback handler is mandatory or optional. Okay, for the most part, obviously when it's mandatory, you need to specify something here. If it's optional, typically it's this method could also return a synchronous return, with a return object. Okay, but when we specify a callback, this is an asynchronous callback. So when in this case, when the network starts polling, right, every 20 whatever this is, 20 seconds, it's going to call a callback handler. Okay, and then when the callback handler is executed, certain things are returned to that callback in the form of an object. a callback return object. So when you click on the callback tab, you'll see that in this particular example, we're returning an object. Remember, it's referenced as a hash on the documentation with two properties. One is called current status and one is called previous status. So those are the properties I can expect to see when the callback is triggered. Okay, so for the callback, for setting up the callback, you can do basically three things, and probably the first one is probably the most common. The first way you can do it is by just specifying an anonymous function here, and we'll show you an example in a second. You can also provide just a JavaScript function name, and then in some cases where you may need to reference or maybe a Ruby method for certain features, you would specify the path back to the Ruby method. And in this particular case, which is probably most likely not used in a lot of scenarios, this is only available to native applications that have the Ruby server available to it. Okay, it's not available in the runtimes or when you're hosting it from a website. So let's take a look at some of these callback examples. So for an anonymous function, if I wanted to execute the network start status notify every 3,000 seconds, this function inside of in this particular syntax here will be executed. So this is an anonymous function. So it's going to execute this function, and here's the callback parameters object. And notice I can refer to it just like a regular JavaScript object. I can say callback parameters dot current state. So in this case, I'm going to check to see if the current state equals connected. Based on the documentation here, it says it'll be connected or disconnected, right? So this is where this current status is. And I spelt it wrong. So it's current status, not current state. So anyway, I need to correct the slide, but it's current status, and then do a data sync based on that. So this is an example of anonymous function. You can do the same anywhere we reference callback handler. You can provide this type of syntax. That's probably the most common way that people are using it. The other way is to actually do a JavaScript function name. So in this example, we have a function that says, start status notify, and I issue that same API. But in this case, I'm referencing a function name. Notice there's no brackets for the function, but just the name of the function. So when this is triggered every 3,000 seconds, this function will be executed, and this params object here will be the object for the callback return parameters. Now, in this case, I'm referencing it this way: params with a bracket and the name of the object property, current status or previous status, in here. So in this case, I did get the syntax right, and I'm doing params with current status. I could have just said params dot current status without the brackets, what have you. But I decided to show it here just so you can see that it's available to both. And then the third case is this Ruby method, like I mentioned before. So maybe I'm doing a blended application, or I'm using JavaScript on my UI, and I want to execute something on Ruby side when this happens, maybe a background sync or what have you. In this case, instead of providing a function name or an anonymous function, I'm just specifying a URL path to my local /app/sync Ruby controller, and it'll run through that method back in the Ruby code. So those are the available ways that you can specify a callback. Okay, let's talk about JavaScript ORM. So ORM is our method for accessing our data structure for RhoMobile applications. So under the covers, we store data in a SQLite database, and we provide this abstracted API to access the database. So you can number one, really not write SQL code if you don't have to. But also number two, so you can we kind of provide two different ways for storing data. The more traditional structured way is using what we call fixed schema, where you're actually defining your tables and indexes and relationships, and it's very SQL orientated. And then the other way, which is the default way, is what we're calling our property bag or our schema-less way of storing data. And in this case, everything is pretty much stored in one big table. And the benefits is, when you're adding new fields or new properties to a particular model, you can add those very easily without any management of schemas. So the thing to point out here is you may have seen a demonstration using RhoStudio to generate a model, right? You've probably seen this. You would right-click in RhoStudio and say Add Model. When you do this in RhoStudio, it's actually generating a Ruby class or Ruby interface to that particular model name, and it's not to be confused or really mixed with doing the same thing in JavaScript. Okay, in JavaScript, you have to create a reference in your application to your model, right? So in the code snippet above, you can see that I'm creating, I'm adding. You do this with the ORM add model method. Okay, so I'm doing an add model, and the only thing you really need to provide is just the name. That's the bare minimum. Okay, so in this case, I'm saying in my JavaScript application, add a model called product. Okay, and I'll show you how to do all the CRUD operations around that. So when I do that, I have a reference to this product model, and I'll be able to add records, update them, delete them. Okay. You don't have to assign. So what this is going to do is return a reference to this ORM model, where you can start doing ORM model APIs like find and create. And I assigned this variable called product model. I didn't have to do that. I could have just said row.orm.addModel, and then to create a reference, and then I would have had to use a get to retrieve that model reference, so I don't have to carry this global variable around. But just for simplicity's sake, I decided to include this in. And like I said before, no property names need to be referenced right now. Like when you do this in RhoStudio, you would say new model and say name, quantity, brand, etc. And all that really did was to kind of give you a blanket UI or a default UI to have those properties available to you. But in this case, I really don't need to provide anything. I just need to create this reference. So this is really important. If you don't do this, if this doesn't run first before I try to access my product model, then you won't be able to exercise any of the functions. Okay, so how do we create records for this model? So let's take a look at that. So the first thing you had to do was create the reference, like I just mentioned before, to the model name called product. And I'm assigning it a variable called product model. And now I can use that product model variable because this product model variable is now an ORM model, okay, class, okay, and it will now have the ability to have many different methods and functions, right, to do. So in this example, we're actually creating a record. So I'm using the product model create method, and the create method takes an object that basically is a property name and value list, right? So this is a JavaScript object. So I could have, had many different property names here. It doesn't really matter, but this will create a reference directly in the database on the local device. And now this new product variable will equal that particular record instance, right, of the product model. Okay, and when it's created, we have a special field called object, which holds the unique ID for that particular record. So you can see in the code here, I'm just logging to the console, the new product, and I'm using the get method to retrieve the property for this particular record that was created. So you can see the output on the console would output this big long hairy string, which is our unique ID for this particular record. Okay, so that's how you would create records just in JavaScript. It's pretty simple and pretty self-explanatory. So now let's talk about how do we get the attribute value. So we just showed an example of using the get method, right? So once the product was created, I could easily say get and then the property name in quotes here to retrieve the value of that particular record. But we also have this, and this is done by this notation, which is probably the mostly used, but you can also do the same thing using .vars, which is a method for this for our ORM models, and then you can reference the object names just like this instead of doing .get. So it's all just a matter of preference, really. There's no advantage or disadvantage of using either one. Just wanted to make sure you knew that that was available. Okay, so how do you set the property values? Let's say we want to update a particular record. Okay, there's two ways you can do it. So the first way is if you use our update attributes method. Okay, so new product is a reference to that particular record, and now I have update attributes method available to me. And just like in the create, I'm going to pass in an object of just property name and value pairs. So in this case, I'm updating my quantity for this particular record to be 25, and update attribute saves it to the database right away. Okay. There are a couple of other methods. If you don't want to save to the database right away for whatever reason, you could set the quantity. You could use the set method, and when I use the set method, it's actually not saving to the database until I issue a save on that particular record. So for whatever reason, maybe you want to do it that way, and that's available to you. Okay, so how do we delete records? Okay, well, once you have a reference to a particular record, just like before when we did update, we now have the ability to delete them, and that's simply by issuing a destroy method. And this will remove the product record right away from the database. It'll delete it from the database. There's another method that's also available called delete all. And now this is done not on the record object, but on the actual model itself that was created up above. Okay, this will delete all records for this particular model, and it'll basically bring the count back down to 0. Again, this is done right in the database right away. So those are your basic, CRUD operations for a particular model using JavaScript. Some other functions that we provide in JavaScript is the ability to find records. So let's say you want to have a page that displays the list of products. How do we do that? Well, like before, we created a reference to our product model class. We now can call the find method. And there's a couple of different parameters you can pass for find. The first parameter will indicate the type of select or find that's being done. In this case, we're finding all records. And what this is going to return is an array of record types. So when I loop through the array and reference products, this products I is going to be an object, a record object for the product model. And then I can do a get and retrieve the name of that particular record. Okay, you can also optionally include a set of query options as a parameter. So if you wanted to not return all of them, but you wanted to provide a certain subset of those, we have the second parameter for the find method is query options. Okay, and in this case, it's an object, and there's a couple of different query options. I'm only showing one of them in this example called conditions. So conditions is part of the query options. And in this case, I'm saying when brand equals Motorola, only return those products that match this condition. And again, this will return an array of objects. The other way you can use find is by just finding the first record. So if I just want to get, maybe you have multiple conditions, but you want to find the first record that equals these conditions, I would do find instead of all. I do find first. And instead of an array, this is going to either provide a blank object, an empty object, or it's going to provide an object that is equal to a record object for that particular model. Okay, so you can see here that and then I would just issue product.get and get the name for this particular record. Another way you can use find is by just counting the record. So this is going to return an integer, obviously, and not an array or an object. It's just going to return a number. So 0 or a number if it found matching these conditions. So let me just show you a little bit more in the documentation where you can find this. So there's two sections. So there's ORM JavaScript and ORM model JavaScript. So ORM JavaScript is about adding models and doing some other things. It's adding and getting. So this is the important method here. So if I look at add model, I can look at this is the model name. Okay. You can also provide if you want to have this model synchronized. Okay. So if I look at the example, in this case, we're adding a product model and we're saying we want it to sync, and we actually specify the properties here. And I'm also specifying a partition. So if I look at this, we can see that here's the property, and there's other choices you have here. So this is where you're actually defining your models, your model definitions. And then when you're actually working on them, this is where you're doing you're using model JavaScript. So we just put your ORM model name here as a notation for your reference to your model. Okay, so when you're looking at this documentation, you can see all those methods that I just gave you an example for. So here's the find, and here's the query type, and here's the query options object like I mentioned before. I just showed you conditions, but I could have equally showed you ordering or order direction or selecting certain fields to retrieve instead of the full object. So this is where you're going to be finding all of your CRUD type of operations for your particular models. Okay, and there's some examples here that you can look at. All right, so let's talk about a couple of different things that you might have to do. As I mentioned before, we've always provided Ruby. That was our foundation for our APIs, and then we've been introducing JavaScript. Okay, in some cases there may be some scenarios that we just don't have what you need for purely in JavaScript, but there's probably an equally available API via Ruby. Now, don't be scared by it because it's really not daunting of a task. We do have several examples for how to use our Ruby APIs, and they're very, very similar in notation. One of them that's quite easily to add to your JavaScript code is when you want to, let's say, use our Ruby APIs for reading a property that may not be available in JavaScript. So in this case, we have a row config object that is available currently just on Ruby that reads from our row config file. So in our row config.txt, I have these two properties that I list in here that are including my API keys for a web service that I use. And I can still access them in JavaScript, and you can access them right from your code. Now, this does have to run inside of our Ruby ERB files. So when you're generating a native application, instead of using HTML, if you use ERB extensions, it'll recognize the Ruby syntax inside. So you specify Ruby syntax just with a less than %equals, and then I'm issuing my Ruby statement to retrieve this particular configuration option. So that's really one simple way. Like I said, it's good for getting or setting even properties, but it needs to run inside of ERB files. You won't see this translate into a result just running straight from HTML or running your application from a web server. The other situation is where you actually have to write some more deeper Ruby code. And you may actually have to execute a whole series of Ruby APIs or methods. The good news is this is very easily done through AJAX calls. So remember, RhoMobile applications are pretty much a local web server running on your device, and everything is available to the local application. So again, this situation is only for local applications that have been developed with RhoMobile, and the way to do it is through Ajax. So uh, let's say you need to write some code in Ruby. You would define a method. You would create a Ruby. You would create a folder, let's say called bridge, right? And you create a Ruby controller. And there's some generators for this inside of RhoStudio. Just like you would generate a model, you can just right click and say add model bridge and then delete all the files and just to get the controller, right? So it would generate some stub functions for you, and everything is accessible by a URL. So it's like it's folder name basically, and then slash method. So I have bridge, and then slash some action. So in my JavaScript, I can get to this. I can call this Ruby method by issuing an Ajax call to, remember this is all local server, so I need to specify the right path. That's the most important thing. So I'm doing /app/bridge/some action, which will trigger this set of Ruby code in this bridge controller. Okay, so it'll do something here maybe, and I'll show you a real example in a second. And then it may need to talk back to the JavaScript. It may need to indicate that it finished or return some results. And so we have a way to talk back, and that's through our web view class. And we have an execute.js method that allows you to execute some JavaScript. So maybe you want to call a function back in here, passing in a parameter or some data, so it can talk back from Ruby. So this is very useful, very handy, not super duper complex. So let me show you a real example. So I have an application where I wanted to use the camera API, and right now, version 4.0, we didn't supply the camera API as a new JavaScript common API. So I needed to use Ruby. So I set it up in my application, this folder called camera with a controller. And inside the controller, I have a method, which I'll show you in a second, which is take picture with default camera. So in my JavaScript, when I clicked on the button to take the picture, I issued this Ajax call, passed in this URL to go to /app/camera/take picture, and then this take picture is going to just call this JavaScript function to assign the image object on my page, change the attribute so the source equals the wherever the image is stored locally. And that's all I need to do on my JavaScript side is to do that. And on the Ruby side, so in my camera controller, I essentially just copied and pasted this snippet from the kitchen sink. So I defined my method called take picture with default camera. Remember, this is what I called here, /camera app/camera/take picture with default camera. And it's going to run through this Ruby code, which is going to take a picture. And if you look at the API documentation for camera, it's a callback as the first parameter, and then some properties. So I want to make sure that the picture is small, 640 by 480, and when the person either cancels or takes a picture, this Ruby method is going to be executed, which is right here. And now I have a reference to my where the file is locally on the device. Again, this was just copy and paste from the kitchen sink application. And the only thing I added was what to do with that. So this is a string that represents where the file is, and this is where I talk back to my JavaScript for changing the image source on the particular view that's displaying the image. Okay, so that's just a simple example, just in case you need it, on how to talk from JavaScript to Ruby APIs and still pretty much have everything in JavaScript. So as far as, okay, what to do, we're kind of wrapping up here. What to do about learning these APIs, there's a lot of different good resources here. One is go through the documentation. All the APIs are documented on their methods and properties. They have some examples with them. We also have an example application that was meant for developers called Kitchen Sink. So if you go to the documentation site and go to the Kitchen Sink example, you can download the project, and which is just up on GitHub, and you can download the application to get going. This guide kind of explains what's going on in the kitchen sink, but for the most part, you can pretty much just look at the kitchen sink public JavaScript samples folder, and all of the JavaScript for each of the particular examples are in there. So you can, we're just trying to look for common use cases. Doesn't cover every single situation or scenario, but it covers the most common scenarios, and you can look at these JavaScript files, and it's really more for a learning tool, so you can learn some of the APIs. Okay. The other really good resource is our RMS testing Git repository. So if you go to the RhoMobile GitHub repository, and then there's a RMS-testing repo. This is what we use for automated testing. So if you go to auto, feature def, auto common spec app, you'll see a whole bunch of folders here for each of the APIs essentially. And you can click on them, and let me just do that actually so you can see it. So I go to github.com/RhoMobile, go to RMS testing, and this is open. This is not a private repo. I go to auto, feature definition, auto common spec, app, and then there's a whole bunch. So if I picked maybe card reader test, you could see some of the, that's probably not a good one, but you could see card reader spec. I'm sorry, I clicked on the wrong one. You can see get all card reader, right? Open card reader. I'm sorry, I clicked the wrong one again, right? Card reader JavaScript spec. So if you click on that, you can look at a lot of the descriptions here, right? Card reader open. So here's how we're issuing. There's a lot of like JavaScript codes using this Jasmine framework, if you're familiar with Jasmine. But if you scroll through here, you can actually see some examples of, auto enter default value is true, right? So that's another good learning tool. The other way to kind of explore it, I didn't put on my slide deck, but we have another session on it that I'm doing, is to go through Winery. And we use Winery was very good for on-device debug of JavaScript, but it's also good just kind of explore the API. So we have a whole other session on that. I won't spend any time talking about it. So those would be my recommendations to get started with learning these APIs. And that's about it. Thank you.